Hello, welcome back to Cinderella Math. Today I'll be doing solving exponential equations with something I lovingly refer to as the Kapoosh method. That's certainly not a real word. I came up with it, and hopefully I can explain why that is what I call it here once I get into the examples. Yeah, so this is an Algebra 2 or pre-calculus topic, could really be both. So yeah, let's go ahead and jump in. We'll start easy and then we'll slowly work our way up. So example 1, let's have 3 to the x plus 4 equals 3 to the 7x. So see how we have a base of 3 on both sides. That means you get to kapoosh it. So they can just go away. That is totally fine. Kapoosh, kapoosh. If they're the same, you kapoosh once, twice, done. And now it's just x plus 4 equals 7x. Solve. I'll minus x. There's a 1 there if you need it. 4 is 6x. Divide 6. 4 6 reduces to 2/3. So if they're the same, simply kapoosh and be done with it. Solve. Let me make that just a little bit harder. Example 2. Let's have 4 to the 2x minus 1 times 4 to the x equals 4 to the, just making these up, 5x plus 3. So they do all have a base of 4, but we're only allowed to kapoosh twice. So on this left-hand side, we need to get this into one chunk of material. We know when we're timesing, we really add the exponents. So just a quick sub bar here. Pretend it's like a to the 4th times a to the 5th. You keep the a and you add, so that would be a to the 9th, right? That's back from Algebra 1. So here, we're going to keep, back to our example 2, we're going to keep the 4 and add this exponent with this one. So 2x minus 1 plus x. 2x plus x, we could say that's 3x minus 1. And the other side was fine. It was just one chunk of information, so we don't have to do anything with that right side. And now, here comes the fun part. We have a 4 here, a 4 here, kapoosh, kapoosh. 3x minus 1 is 5x plus 3. I'm going to minus 3x. That's 2x minus 3 is negative 4. Divide 2 is negative 2. And done. So a little bit tricky there, but again, we just remember that old algebra rule that when we're multiplying, we really add, we keep the base, and then we add the exponents. All right, what if it's not kapooshable? Example 3. 3 to the x plus 1 is 81. So we cannot kapoosh that because 3 is not the same as 81. So we're going to try to get it kapooshable. Now this won't always work, and that's for another video. So for today, this will always work. But in the future, look out for another video where you cannot kapoosh, and we do it differently. But here, let's try to get 81 to look like 3. So let's come off to the side here, and let's break down 81. We know that's 9 times 9, and then 3, 3, 3, 3. So 1, 2, 3, 4. So 3, 4 times is 81. So we're just going to make that substitution. We're going to say bye-bye 81 and substitute in that that's 3 to the power 4. This side we're going to just leave. And now we can do it. 3, 3. Kapoosh, kapoosh. X plus 1 is 4, minusing 1, and x is 3. So we had to change the 81 to have the same base as the left side. It became kapooshable, and we were done. Okay, let me find another one here. Okay, here's our next one, number 4. 5 to the x squared plus 8 equals 125 to the 2x. So again, not kapooshable, but let's see if we can get it kapooshable. So usually you're going to work with the bigger number. I wouldn't say always, but usually we're going to bring the bigger number. So 125 off to the side. That's 25 times 5, which is 5 and 5. 1, 2, 3. So 125 is 5 3 times. If you just know that in your head, you don't need to do the tree. If you want to use a calculator to help you with that, feel free. But you can see it clearly in the tree that 125 is 5 cubed. So let's make that substitution. This is 5 cubed, but then you still have the power. You didn't mess with that. So just bring that straight down. I usually put it in parentheses. And then over here was fine. And now, kapoosh, kapoosh. Leaving us x squared plus 8 equals, you can distribute here and get 6x. Oof, this one's not just super easy solve and be done. That is a quadratic. We need to get this guy set to 0. So let's minus 6x, set to 0, minus 6x. So that's x squared minus 6x plus 8. Remember to put it in standard form, which is descending order of the exponents, right? And now let's factor. You can do this however you want. I'm going to be doing my magic X method. I did not invent that. It's a common method to factor trinomials. I'm going to make an X off to the side. I'm going to put that invisible 1. And then I'm going to do front number times back number. 1 times 8 is 8. And then middle number is -6. So basically you do the A times the C. And you put the B down. And now I call this magic X MA. Go through your times tables. We need to find the two numbers that multiply to 8 but add to -6. I think if we did 4 times 2 but make them both negative, negative times negative would multiply to 8. You owe me 4 plus you owe me 2, you would owe me 6. So this would factor. See this x squared, 1 for me, 1 for you, and our magic numbers of -4, -2. Set each one of your factors to 0. This would whip around and be 2. This would whip around and be 4. And there we are. So we do have 2 answers because we were working with a quadratic. So that's not very surprising that we got 2 answers. And there we are. Great. Let me see what else I can do here. That was example 4. Let me do example 5. Okay, made that up in my head, so this may not turn out really pretty, but that's okay. All right. Ooh, goodness. Definitely not kapooshable until we get all these bases the same. So I kind of ignore the fraction. Just looking, we'll come back to it. Don't worry. Just looking at the 64 and the 16, probably your eyes drawn to the 16, because pretty easily we know that 4 squared is 16. So let's just go ahead and change that. 4 squared, and then we did not mess with the power, so just leave that x plus 5. I put it in parentheses because it will get distributed. So now that we changed that to a 4, we need to change everything to a 4. Again, I kind of save the fractions for last because Usually they're annoying, but it's fine. So I'm going to come to the 64. Let's change this. 4 to what power is 64? You can go on your calculator or you can do a tree, whatever you want, and you will pretty quickly get that 4 to the third power is 64, or you might just have that memorized. So we're going to say this is 4 to the third, and then the x just comes down. Technically, you can do it like that if you want. And now, oh man, we got to change this 1/16. So 4 to what power is 1/16? The way I like to do it is just look at the denominator. 4 to what power is 16? Well, we know that's 2. And then because it's a fraction, negate the power, right? So remember, again, this is just back to algebra 1 real fast. If you had a to the -3, back in algebra 1, we were taught that typically we don't work with negative exponents. So we make a fraction and we send that to the bottom. So if you go back up to our problem, 4 to the -2, let me come down here, 4 to the -2, you would make a fraction and you would send that to the bottom, but then 4 squared is 16. So again, kind of just look at the denominator, figure that power out, and then negate it. So this is going to be 4 to the -2, and then we still have that times. All right, so I would like to kapoosh, but I can't because I can only do it twice. So this left-hand side needs to come together, keep the base, and the rule when you are multiplying is to add the exponent. So we're going to do -2 plus this guy. You can go ahead distribute. And then same thing, we can go ahead distribute here. And now we're finally ready, my favorite part, kapoosh, kapoosh. So we have -2 plus 3x is 2x plus 10. I'm going to subtract 2x to keep this positive x, add 2, and x is 12. Actually, that came out very nice for me, just making that up in my head. All right. Let me do one with E, and then we might be done. Example 6. Remember, E is just a number. Kind of like pi. E is just such a cool number, and that comes up so often, he got his own name. So let's say we have E to the 4x times E to the x squared equals E to the 12th. So don't be scared by E. We're going to just work it the same way. I want to kapoosh, but this side, I need to get this together. We're going to keep our base, which is E, and when we're multiplying, the rule is we really add the exponents. So that'll be 4x plus x squared. The other side was fine. Now we have E and E, kapoosh, kapoosh. So you do it the same exact way. Don't be scared of E. So we have 4x plus x squared equals 12. I'm going to go ahead and rewrite the quadratic in standard form. So we're going to switch these two to put x squared plus 4x equals 12. That looks better. Let's set this to 0 by minusing 12. I'm going to come up here for room. X squared plus 4x minus 12 is 0, which is what we want. We always want to set our quadratics to 0. And then let's see if this factors. You can factor any way you like. I do my magic X. First times last. Middle number. Magic MA. What multiplies to -12 adds to 4. If you had 6 and then owe me 2, that would multiply to -12 and add to 4. So this would factor. See this x squared? 1 for you, 1 for me. And we had a positive 6 and a -2. Set to 0, set to 0. That would be 2, and that would be -6. And done. So don't be scared by E. Um, I really think that's pretty much the gist. That's what I would like to do today. That is solving exponential equations using quote unquote Kapoosh method. I know that's a silly word, but it might help you remember. And again, you're probably seeing this in an Algebra 2 or a pre-cal. Good luck to you. I have other topics on here. If you need any help or you need to request a topic, please just leave me a comment. I hope this was useful for you and that you're having a great day. Hope to see you back here soon.